Hello, everybody. Welcome to this LightWare LiDAR webinar. Today, we're excited to introduce the GRF-250, the first in our GRF series of mid-range laser rangefinders, specifically designed for seamless gimbal integration. My name is Nadia Nilsen, and I am the Group CEO at LightWare LiDAR. I've been involved in the LiDAR and laser rangefinder space for over 20 years. I joined LightWare in 2015 as CFO. Then I served as COO before taking the reins as CEO in August 2022. It's both a pleasure and a privilege to lead this incredible team and to collaborate with esteemed customers like yourselves. Johann, can you please introduce yourself?
Hello, everyone. I'm Johann de Wet. I'm the engineering manager here at LightWare LiDAR, and I have the real privilege of leading an exceptional team of engineers who are passionate about developing innovative products like the GRF-250, which we're excited to show you here today. So I personally have been in the aerospace industry much of my career, where I have designed galley equipment for commercial airliners, executing modifications on manned aircraft, as well as unmanned aircraft, designing subsystems for these unmanned aircraft, and I've even been involved with flight simulators. So it is now an absolute pleasure to be part of the LightWare LiDAR team, designing world-class sensors for some of the platforms that I've just mentioned. In this webinar today, we'll guide you through the GRF-250's application details. We'll touch on some specifications as well as some advanced features. And in just a moment, we'll be sharing an unboxing of one of these brand new products, and we'll even include a brief performance demonstration. So definitely stay tuned.
Thank you, Johann. I hope you are as excited to have a look at the GRF-250 as we are to show you. Our engineers are on standby to answer any questions that you may have, so please feel free to post them in the Q&A tool at the bottom of your screen, and we will answer them as soon as we possibly can. Towards the end of the webinar, we will choose some of the more common or interesting questions to answer for you live as well. LightWare has been collaborating and innovating with the UAV industry since 2012. Our high-performing micro LiDAR distance sensors were specifically designed for UAV applications. We excel at creating ultra-light, highly compact sensors for drone applications like above-ground altitude measurement, terrain following, position hold, detect and avoid, and SLAM. We're confident in saying that in these applications, LightWare LiDAR sensors outperform any other on the market, and we're proud to be the LiDAR of choice for many of the leading UAV manufacturers worldwide. Our collaboration with the UAV industry continues with the development of our GRF series. This family of gimbal laser rangefinders are being developed in direct response to customer demand. UAV gimbal systems are crucial in search and rescue operations and disaster management situations, and they provide critical situational awareness for law enforcement and security. They are invaluable tools in wildlife preservation, as well as intelligence, surveillance, and reconnaissance missions. Currently, there aren't any high-performing, reputable mid-range laser rangefinders on the market that are well suited for small gimbals where space, weight, and costs are critical. When integrated into gimbals, these laser rangefinders work in harmony with the other sensors, like high-resolution cameras or thermal images, to deliver a comprehensive view of the object. The LRF provides precise distance data that enhances the focus of the camera systems, especially over long ranges and in challenging lighting conditions. Additionally, this depth measurement allows for accurate localization and active tracking of the observed object. By performing automated triangulation, your gimbal system can precisely calculate the GPS coordinates of the object and relay this information to ground control, supporting whatever action your mission requires. Johann, will you please tell our audience what they can expect from the LightWare engineering team after the GRF-250?
Yes, certainly, Nadia. So the GRF-250 is the first in our mid-range gimbal rangefinder series, known as the GRF series. So we're currently developing the GRF-500, which, as the name suggests, is a 500-meter laser rangefinder that we plan to launch in the first quarter of 2025. Then additionally, and something that we're very excited about, is the highly anticipated GRF-1000. And of course, this will be our 1,000-meter laser rangefinder, which we expect to launch around mid of next year. So that's mid of 2025. So be sure to keep an eye out for those launch dates as those webinars approach.
Thank you. Johann, the GRF series of laser rangefinders all use 905 nanometer wavelength light, but surely the 1550 nanometer is more suited for longer ranges. Why use 905?
Yes, so 1550 nanometers is slightly better suited for long-range LiDAR, so you are correct, but we have managed to figure out ways to use 905 nanometer tech to reach slightly longer ranges. So the big issue with 1550 nanometers is that the transmitters and the receivers are still extremely expensive. And I mean, I'm talking about an order of magnitude of in excess of $100 per diode. And obviously you need the receiving and the transmitting diode. So 905 nanometer technology just makes a lot more commercial sense when considering the types of applications that we have designed this rangefinder for.
I'm assuming that that also comes with some technical difficulties or challenges to reach these longer ranges. What difficulties did you face in the development of the GRF-250? And I'm assuming they're more pronounced in the GRF-500 and 1000 you just mentioned.
It was certainly an interesting journey to basically find the optimal point between the competing variables. Our technology is basically built on three pillars. On the one side, you're looking at electronics, you're looking at optics on the second side, and then thirdly, and this is the actual intelligence in our systems, and this is the firmware. So when considering the electronics, of course, you must start with the most premium electronic components, especially on the laser and the receiver diodes. And then there's obviously the fine balancing act between the laser power. We just noted why 905 is slightly more challenging to get those longer ranges, and the associated pulse characteristics of that laser to achieve the range and still be eye safe. Then secondly, as I mentioned, the optics have to be designed to achieve the range that you have in your requirement, and you have to sacrifice short range performance to achieve these longer ranges, as the perfect optical alignment for longer ranges is very different to a shorter range product. Then lastly, the firmware, as I've mentioned, the firmware runs the update rate, and the update rate is critical. So you really have to slow this down to reach the range performance and still provide good accuracy.
And all of that in a super small form factor that weighs so little. That's quite an achievement. Well done to you and your team, Johann. Shall we have a look at the GRF-250?
Okay, so this is the GRF-250. The sensor has a form factor of only 32 by 31 by 20 millimeters, and it weighs a mere 10.65 grams, so it's really super light. It has two connection ports, one for USB-C to allow for connection with a computer, and a port for the sensor's communication and power cable, which you will find in the bottom of your packaging box over here.
Johann, what communication protocols are available on the GRF-250?
So the GRF-250 offers both serial UART as well as I2C communication protocols, and it'll automatically adapt to the protocol you use to communicate with it. The product is compatible with LightWare Studio, Arduino, and Raspberry Pi, and we're working with the amazing guys at ArduPilot and PX4 to conclude the PixHawk compatibility really soon.
And how is it mounted and installed?
So the rangefinder is designed to be mounted on a reference plate that allows for system alignment, and here you will see the 3 mounting feet for installation. The device has a beam divergence of less than half a degree and a mechanical bore sight of 1.5 degrees with respect to the mechanical interface, which is a 3-foot mounting surface that I mentioned earlier. The front face of the sensor is IP67 rated, and the lenses are meant to be exposed with a sealing surface for integration using a gasket of sorts here on this flange.
I think we are all dying to see it operate live. Johann, while you are connecting the device there, tell us about the power supply and the power consumption, please.
All right, so the sensor requires 5 volts power, and it typically uses around about 120 milliamps, and that's except during startup, at which it surges at around about 250 milliamps. So one of the advanced features on this device, and we think this is a really cool feature, is its power saving mode or sleep mode. So during which all ranging and processing functions will be halted, and the power consumption will drop to around about 30% of normal use. This feature is only available for serial UART interfacing, and basically any activity on the serial line will wake the GRF-250 to resume normal operations. Then when connecting the USB, please plug the USB cable into the sensor before connecting the cable to your computer. Okay, getting started with any LightWare LiDAR sensor is really super easy. So simply download LightWare Studio from our website and connect your device. I think for ease of access to our software, we'll just post a link in the chat. See, that's just come through. So LightWare Studio is a free application. It's available for all the big platforms, Windows, Mac operating systems, as well as Linux. And it's basically the gateway to configuring your laser rangefinder and to visualize your data. The software empowers you to customize settings, fine-tune sensor parameters, and easily analyze the data. It also facilitates firmware upgrades and in-field diagnostics and support. So just a quick note on the range performance. Basically, what you can expect from the footage to follow is to see measurements from a minimum of 10 meters to a maximum of 250 meters. And this is on an object with a reflectivity of 40%. And that'll be at an environmental visibility specification of 10 kilometers. And also it's important to note that the target would have to be beam filling. So no smaller than 1.4 by 1.4 meters. Okay, so before we show you this footage though, allow me to briefly paint the scene here for you. We have a GRF-250 mounted atop a telescope with a camera feed showing the scope image. I've aligned the crosshairs with the sensor. So we're basically looking at the world from the sensor's perspective. Okay, right. Let's get to the fun stuff. Let's have a look at this video. This is the image from the scope cam, as I've mentioned, looking through the scope. So you will notice the sensor is pointed at an electrical pylon. So we're basically looking through the structure, and just past the structure of the pylon, we have some vegetation, just some trees in the background. So I think it's really important here to point out that the vegetation in the background is only around 20% reflective. So that's about half of what we specify on our data sheet. This is really important because a lower reflective object is more difficult to try and range. Okay, so you know at LightWare LiDAR, we like to under-promise and over-deliver. So connecting the GRF-250 to Studio is really simple, as I mentioned, using a USB cable. So once again, please first connect your USB-C cable to the device before connecting it to the computer. All right, so we have LightWare Studio running in the window on your left-hand side, and the moment we plug the GRF-250 in, LightWare Studio will automatically detect and identify your device. And for today, we are going to navigate to the 5-signal output window where the 2 object distances are reported. 5 columns are represented, with the pylon being reported in the first column in black and the vegetation or the tree in the background in the second black column. So the device has got an update rate which is configurable from 1 to 50 readings per second, which can be set in the parameters. So setting it to 10 hertz will result in a slightly more stable reading, and essentially it will still read the full 250 meter range at a maximum of 50 hertz. Updating this to, let's say, 25 hertz, that'll just slightly more than double your output rate. But for today's demo and for today's purposes, we're going to run this at full steam, and that is at 50 hertz. The GRF-250 can detect between 1 and a maximum of 5 objects in its line of sight. And of course, if there's only 1 or 2 objects, you will receive only 1 or 2 readings. You will see from the readings that we're currently detecting 2 objects, being obviously the pylon as the closest target at around 86 meters, and the trees in the background, and this is the second and most furthest target at around 280 meters. So I just want to highlight something here again. We're ranging something that is poorly reflecting at 50 hertz, and we're measuring 280 meters. So this is far greater than our specification. I just have to highlight that. For different targets to be discriminated, they need to be at least 20 meters apart. Something else that I also just want to point out is the signal strength output, and that is your second output just next to your range. And this is reported along with every measurement, and is basically a metric that can be used for a sort of confidence indicator. So this is around 24 decibels for the shorter range object and 20 decibels for the trees at 280 meters.
And what is the accuracy, Johann?
Accuracy, you can expect anything between plus or minus 50 centimeters, and this is across the full range, so up until 250 meters.
And resolution?
Resolution-wise, we're looking at 10 centimeters, so that's 0.1 meters.
Thank you.
So the product also offers customer selectable first and last pulse detection, which means it'll only output the first object that the laser rangefinder encounters, as well as the last. So of course, once again, if there's only one object, you will only have one measurement. This feature is extremely helpful to penetrate foliage from treetops or penetrate through environmental conditions like mist, dust, rain, and even snow.
Oh, wow, Johann, that's incredible for such a compact device. Tell us about the operating temperature, eye safety, and approvals, please.
Of course. So it has an operating temperature specification of negative 20 degrees C up until a maximum of 60 degrees Celsius. And it has a class 1M eye safety classification, and the product is designed for CE, so we can self-certify, but we prefer third-party testing, which is scheduled for the end of September.
And are there any accessories our audience should know about?
Indeed. So we have a Pixhawk adapter available as an optional extra for the GRF-250. It looks like this and is meant to ease integration with a Cube Pilot. We also have a generic breakout board with different types of connectors available, which pretty much looks like this. And you'll notice a whole number of possible connectors and headers featured on the board. And of course, a USB-C cable, all of which can be purchased from our web store. So speaking of web store, Nadia, perhaps now is a good time to talk about the price and availability of the GRF-250.
Thank you, Johann, for a brilliant demonstration and for walking us through the technical details. I'm sure it's been super helpful for our audience as well. The GRF-250 is now live on our website. We will post a direct product page link for you in the chat right now. And our sales team is on standby to assist with any quotations. This super compact, ultralight, yet very powerful LRF will retail for $349 US dollars, with discount available, volume discounts available, of course. We currently have 130 units in our stores ready to ship to the first customers who place orders. Please don't wait. We do expect this first batch of GRF-250s to sell out fast. We also have a special gift for our audience today. Each attendee will receive a 20% discount voucher. We will share the discount voucher code with you at the end of the webinar, so please stay tuned. Let's have a quick look at some of those questions that's been coming through. Johann, first question. Did I hear the range specifications correct as 10 meters to 250 meters, and what does it output below 10 meters?
Okay, so for readings under 10 meters, the device will report an out of range message, for which I believe the actual output value is a -1. What we have to remember here is that this device is optimized to achieve the 250 meter range with 50 centimeter accuracy, and obviously at an update rate of 50 hertz. So if shorter ranges are what is required, there are other devices in the LightWare stable that can offer that, along with greater accuracy and faster update rates, which are better suited for shorter ranges.
Okay, next question. Any specific reason for the max update rate of 50 hertz? Why not 100 hertz?
Okay, so the answer to this question is twofold. Firstly, the update rate of 50 hertz was selected because we've gathered that most camera systems run at a frame rate of between 20 and 50 hertz. So we made provisioning for matching the laser rangefinder update rate with the camera frame rate, and this is up to a maximum of 50 hertz. Then secondly, and almost more importantly, one needs to really slow down the update rate to fully benefit from a LiDAR's range and accuracy capabilities. So slower update rates allow for greater range readings and superior accuracy readings.
Thanks, Johan. Last question here. Can you please explain what is meant by 10-kilometer visibility and beam filling targets?
Okay, so I'll split this into two again. Just considering the 10-kilometer visibility, what this means is essentially that the environmental conditions during a bright and clear sunny day allow an unassisted human eye to see a distance of 10 kilometers. Okay, so basically this means there's no dust or smog that's present in the environment. And then just touching on the beam filling side of the question, when considering the subject of the beam filling target, we made mention earlier that the GRF-250 has a beam divergence of a half a degree, right? So this essentially means that there's a cone of light that is emitted from the laser diode that as the distance from the LiDAR increases, the spot size also grows at a rate of that half a degree relative to the distance. So for example, at 125 meters, that'll be half the range specification, you can expect a laser spot size of that'll be half, so 0.7 by 0.7 meters. And this would be beam filling at that distance, right? So at 250 meters, that spot has now grown and is now the 1.4 by 1.4 meters in size. I hope that answers the question.
Thank you so much. We will be at DroneX in London on 24 and 25 September, where we will showcase the GRF-250. So if you're planning to attend, please visit us at booth D60. That's D60. We've come to the end of our webinar, and it's been a great pleasure to present the GRF-250 to you today. Thank you so much for joining us. Thank you to Johann de Wet for taking us through the technical detail, and a heartfelt thank you for everyone supporting behind the scenes to make this a successful webinar. Please don't forget to place your orders. We don't want you to miss out and be disappointed. We will share that discount voucher with you on the screen now. And thanks again, wishing you all a wonderful day further.